All right, so today we're in section 1.4 to 1.5. Both sections combine this concept of subtracting integers and rational numbers. Okay, so in example 1, we don't have terms, and someone just said it. We don't have terms here because it's the same thing as what we learned in sections 1.2 and 1.3. All right, and we have our saying. You guys remember our saying? Our little rhyme that we have? Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. And those rules apply here too. I look at the sign of the number, and every number has a sign. The sign's in front of the number, okay? So in the first question, 1 minus 4, I had someone ask me in one of the earlier classes, well, I don't see an operation between the numbers. You know, they recognize that 4 was negative, but then where's the subtraction or the addition sign? So here's what I need you to understand. The subtraction sign is the same thing as a negative, okay? 4 is negative. You're taking 4 from 1. It's the same thing. All right, so 1 is positive and 4 is negative. So is that same sign or different? One's positive, one's negative. Different signs, okay? So it's just they're different signs, okay? So since they're different, I subtract their absolute values to get 3. And would my answer be positive 3 or negative 3? Negative. Negative, why?
Because 4 is the larger number.
4 is the larger number. Okay? So 4 is the larger number, so it's negative 3. All right, what about negative 5 minus 2? First question I ask is same sign or different?
Same.
They are the same. They're both negative. 5 is negative and 2 is negative. Why? Because of the subtraction sign. You say, that's a subtraction sign. Yes, that means negative. That's the same thing. Establish it, same sign. What's negative 5 minus 2, guys? What's negative 5 minus 2? It's negative 7. Same sign, add and keep. Negative 5 minus 2, same signs, add their absolute values. 7, keep the negative. Keep the negative. All right, what do you see here on number 3? Hold your question. You see a double negative, very good. And double negative changes to positive, and you need to do that before you do any operations. You've got to change that. So we change it to a positive, and now 6 plus 5 is 11. All right, so I want you to do the rest of the questions on this slide, and then we're going to compare our answers. Okay, so we have a double negative in front of the expression. All right, we have the double negative out here, which changes to a positive, and then 7 minus 3 is 4. Is 4. All right, now in the next one, what's 3 minus 12? What's 3 minus 12, Kyle?
9.
Okay, 9 or? Negative 9. Very good. Why is my answer negative? Can anybody tell me why is my answer negative, Miles?
Because when you have different signs, you subtract and take the sign of the larger number, and 12 is the larger number, and it's negative.
Very good. Very good. All right, so on the next one, we have a double negative in front of 13. That changes to a positive, and it's 5. On number 3, double negative again. Can you tell a pattern at all? Your book loves double negatives.
Yeah.
Okay, you're going to see them a lot. It's 5 plus 4, guys. 9.
9.
And 9 minus 17 is negative 8. Anybody get them all? Anybody get them all? Anybody miss 1? Maybe just miss 1? All right, so we're still tweaking this, okay? We're still working through the examples and the homework assignments. This is not when you have to have the concept mastered, okay? That's not until next week. So this week we're still working through, little mistakes that you might be making. I know overall you understand the concept of integers, but we still have to kind of fine-tune some of these questions. All right, example 2. Okay, now in example 2, we have fractions. We need to first look for a common denominator. Okay, need to make sure we have a common denominator before we can do anything. We also need to check our signs. Okay, so in number 1, what do you see there in number 1 that we need to pay attention to? What do you see?
Double negative.
We have a common denominator, and we also have a double negative. That double negative we have to take care of before we can do anything else. Okay? So we have 1/3. The double negative changes to a positive. So now we have 1/3 plus 1/3. Do we add denominators when we add fractions?
No.
No, we don't. So what's 1 plus 1? 2/3. All right, so this one is about as basic as it comes as far as the types of problems you're going to see. I'm trying to give you a wide variety of problems you might see on a homework or quiz question, and that's why we see a mixed number in number 2. All right, now, you can subtract these and borrow. However, when you're dealing with positive and negative numbers, it opens up a few more mistakes that you can make. Okay, so I actually not sure which way your book does it. They might do the borrowing technique, but I prefer to change it to an improper fraction. Okay, I've just found over the years there's fewer mistakes if you do it this way. Now remember, when we change a negative fraction to improper, we do not pay attention to the negative. What is 3 1/3 as an improper fraction? What is it? Just tell me.
10/3.
10/3. And now bring down your negative. Don't do -3 times 3 plus 1. That's -8. Okay, don't do that. Just change it and then bring your negative down. Now, is this same sign or different? Is this same sign or different? What do you think? It is same. They are both negative. You say, well, the second one's subtraction. It's the same thing. All right, so we have to train our brains to see that a subtraction sign means that the next integer or rational number is negative. All right, so what's -10 minus 2?
8/3.
Nope. What's -10 minus 2? Same sign, add
And keep.
and keep. -12.
Oh,
What's up? Yeah. What's up?
Okay, you see a subtraction sign and you might think I need to subtract, but remember they're both negative, so you add and keep. Can you reduce this?
Yes.
Absolutely, -4. Oh my goodness, number 3, we have a whole number. How are we going to change a whole number to a fraction? 4/1. Now we've got another problem. Okay, what's -5.5 as an improper fraction? 11/2. All right. So I can subtract them, right? I can just subtract them. Why?
They need a common denominator.
Common denominator. Go ahead and create your equivalent fraction and subtract. All right, go ahead and finish solving this one. What's my LCD? 2. Okay, so I multiply the first fraction, top and bottom, by 2. 8/2. What's 8 minus 11?
3.
3? Why -3?
Negative.
Why?
Negative.
11 is big.
Because 11's bigger and it's negative. Think about it this way. 8 minus 8 is 0. So 8 minus 11 has to be negative. All right, we can think about it practically also. All right, either answer is acceptable as long as it's reduced. Okay, -3/2 or -1.5. All right. Example 3, decimals. So do you think we're going to treat our signs any different? Are we going to treat our signs any different? Okay, no, our rules are still the same. Okay, it's just now we have decimals, which is not a big deal because we know how to line up our decimal and add or subtract. On the first one, 2.4 minus 5.6, same sign or different?
Different.
They are different. So what do we do to the absolute values?
Subtract.
We subtract them. 5.6 minus 2.4. Remember, these are absolute values that we're subtracting. Why did I put 5.6 on top? I put the larger absolute value on top, okay? Just like, you know, my regular subtraction rules. All right, so now when I subtract them, I get 3.2. But is my answer positive or negative?
Negative.
Why?
Because 5.6 negative and it's bigger.
Exactly. Okay? And that's how you would solve that. All right, I want you to try number 2. What do we see first? that we have to take care of?
A double negative.
The double negative. And remember, both negatives cancel out and become a positive. So both of them, I know it's like this, chain reaction. Negative, you like those hand motions? Negative 8.8 plus 8.8. What do you call these? We just talked about it. Okay, yes, but additive inverse. Yes, and I know that because of my additive inverse property, it says take a number and it's additive inverse, and it's going to be 0. I put a line through it so you don't think it's O. I know, you want a bunch of those on the quiz?
Yeah.
All right, and if you write additive inverse next to it, I'll give you a bonus point. I'll be impressed that you remember that. Okay, I just want to look at example 4 and introduce it to you. I don't know if we'll finish it today. All right, how do you think the commutative property could benefit us when we're adding or subtracting fractions and decimals? How do you think it could work to our benefit? Since we don't have calc, cut down on some of our work.
We just
Sure.
add the negatives and positives together.
Okay.
And we might have added inverse properties.
Okay, so you're looking for the inverse. Okay, you're looking for inverses. You're also looking for values that might give you a whole number. That would be nice, so you don't have to deal with fractions. All right, so let's look at the first one. Negative 2 minus 2/5 plus 1 3/5. Okay, well, if I was working left to right, I would have to find an LCD, right?
Yeah.
Well, why don't I work my fractions first and see what comes from that? All right, so commutative property says, let's rearrange these. Negative 2/5 plus, guys, change it, okay? Just make sure you change those mixed numbers to improper fractions. You will make fewer mistakes if you do that. What's 1 3/5 as a fraction?
8/5.
Improper. Yes, 8/5. Minus 2, okay? So what's negative 2 plus 8? Okay, negative 6/5. Minus, what am I going to have to multiply 2 by to get a denominator of 5? Because this is technically 2/1. So what do I have to multiply it? 5, top and bottom, so minus 10/5. All right, and now what's negative 6 minus 10?
4/5.
Negative 6 minus 10? Whoa, same sign or different? Did I do something wrong?
It's 4. It's just 4.
It's just 6.
Yep.
It's negative 10.
Why is it positive 6, not negative? Because 8 is bigger. 8 is bigger. So 6 minus 10, you are right, is negative 4/5. Okay? Hey, nobody's perfect. Maybe I did it on purpose. Keep you on your toes. Okay? All right, try to use, guys, get rid of that double negative to start. See how you would rearrange that. I can kind of see maybe one way that I would rearrange these numbers to make it a little easier. Which numbers did you rearrange? Which numbers did you rearrange?
4.3 and 3.3.
Okay. What about if I do 7.8 plus 1.2? Why would I want to match those together? It's going to end up being a whole number. Okay. And then I have plus 4.3 minus 3.3. Why would I want to match those together? Then the decimals will cancel out. Okay, so this becomes 9, and then 4.3 minus 3.3 becomes 1, and then it's 10. It's 10. All right, and that's everything you need to know for part 1. Okay. Part 1 of this lesson.